and today we'll continue with what we were doing last class with graphing transformations of trigonometric functions. So to graph a transformation, we just recognize that when you see something like -3 sine t plus 1, this is just like when we were doing transformations, -3f of x plus 1. So the plus 1 is a vertical displacement, which means that the middle of the graph has been moved up 1. So first I draw a dotted line to indicate the center of the graph. The 3 is amplitude. Amplitude is always a positive number, and that tells you how much you go above and below the middle line. So from the center we go up 3 and down 3. So the whole wave is going to be between those two red lines. So the vertical displacement is 1. Now the negative sign in front of the 3 means that we have a reflection. So now all I need to know is, what does my basic sine look like? So I know my basic sine starts at 0, 0, and then it does one wave up and then back again. And the period of that is 2 pi. And the period of this function has not changed. It's also 2 pi. So now I'm just going to take that graph and reflect it in the x-axis, and then expand it 3 times, so it'll become 3 times taller. So instead of going from 1 to -1, now it goes from -3 to 3. And then I'm going to translate and move it up 1. Okay, so this graph starts in the center and then goes down and comes back up again. And after 2 pi, it's made one complete rotation. So we'll just say that 2 pi is at the end here. So by the time it hits the end, it's come all the way back again. So now I've graphed those 2 points. Halfway between those 2 points is another 0, or another time that it crosses the midpoint. Halfway between 2 zeros is the minimum. And halfway between 2 midline crossings is the maximum. So now I can connect the dots. Concave up, concave down. And that's my transformed sine. Now if I copy and paste that image, I can get the rest of the graph. And there she is. So now the third thing that we'll talk about is the phase shift. The phase shift is also known as the horizontal translation. So when you're dealing with a trigonometric function, a horizontal translation is also called a phase shift. So just like we learned in chapter 1, when you subtract something inside of the function, then it's going to move to the right. And when you add something inside of the function, then it will move to the left. Let's just verify that with the graphing calculator. So first, I'll make sure my calculator is in radian mode. Always use radian mode when you're graphing sines and cosines. So sine x looks like, that's not a very great window. If I zoom number 7, zoom trig, then it gives a much better window. So here's 2 periods of sine. And now if I do sine of x minus 1 over 4, x minus pi over 4. I'm going to just change this so that it's a bit darker than the other graph. You can see it's the exact same as the sine graph, but it's been shifted over to the right by a small amount, by pi over 4. So let's draw that darker graph. this is going from negative 2 pi to 2 pi. This is the standard window for trigonometric functions. From negative 4 to 4. And normally sine starts, basic sine starts at 0, 0 and does one wave like this. But now the starting point has been moved over by a small amount. And that small amount that the starting point has been moved over is your C value. That's pi over 4. So that's the difference between these 2 points on the graph. And we can try it for a cosine graph as well. The basic cosine starts at the top of the graph. Starts at a maximum and goes back to the maximum again after one period. So cosine of x plus 2/3 pi is going to take this basic cosine graph and move it left by 2 pi over 3. So let's just verify that. So we've got the basic cosine first. So here's your basic cosine. It starts at the top, and after one period it ends at the top again. And now if I graph cosine of x plus 2 pi over 3, you can see that that top starting point has been moved to the left by 2 pi over 3. So now it goes from negative 2 pi to 2 pi, negative 4 to 4, and this maximum here is supposed to start on the y-axis, but now it's been moved over by 2 pi over 3. So now we're going to start to put everything together. We have the A value, which gives us the amplitude, or vertical expansion. We have the C value, which gives a phase shift, or horizontal translation. And we have a D value, which gives us a vertical translation. And because it's negative, that one's going to move the graph down. So the basic cosine graph looks like this. We're going to take that basic shape and expand it 2 times in the y direction, move it pi over 3 units to the left, and down 1. Now if you want to graph this, usually what I do is I start by graphing the vertical displacement. So I'm just going to graph that because that's the middle line of the graph. So that's going to be where we cross the middle, right at negative 1. And the second thing that I graph is amplitude. So amplitude tells you how high and below the middle line the wave's going to go. So the wave starts at negative 1, it's going to go up 2, down 2, up 2, down 2. So I'm just going to draw that in as a dotted line. And that kind of gives me a guideline for the y values of my graph. I know the y values have to be in between those lines. Third thing I do is I use the C value. So instead of starting on the y-axis, I'm going to take that point and I'm going to move it pi over 3 units to the left. So I got to figure out how many boxes pi over 3 is. Let's see. The end is 2 pi. That's 12 boxes. Halfway is going to be pi. 1, 2, 3, 4, 5, 6. There's 6 boxes to get to pi. So that means that each box is pi over 6. So the second box would be 2 pi over 6, which is the same as pi over 3. So if I want to move pi over 3 to the left, that means I'm going 2 boxes to the left. So instead of starting on the y-axis, I start 2 boxes to the left. Okay, and now I can use the period of cosine. The period of cosine is 360 degrees, which is the same as 2 pi, or 12 pi over 6. So that means 12 boxes. So after 12 boxes, I'm going to end up right where I started, at a maximum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right here, I end up at the maximum again. I can also count backwards, but that'll take me off the graph. Now, halfway between two maximums, you find a minimum point. So 1, 2, 3, 4, 5, 6 boxes, and I get to the minimum at the very bottom of those boundaries for the wave. Now, halfway between a minimum and a maximum, you cross the middle line. So after 3 boxes, I'm going to cross the middle. And same thing here. Halfway between a maximum and minimum, you cross the middle line. So I go middle, bottom, middle, top. And this pattern repeats. Now I can copy paste that basic sine graph and connect the dots. It's concave down above the graph, and it's concave up underneath that middle line. And it crosses the middle line with a slope of 1 and -1. Now, I really don't want to use the calculator only to draw this graph. It makes it very difficult because you really can't see the boxes very clearly. It's hard to determine these numbers exactly. But I can use my calculator to verify that my graph is correct. So I'm graphing 2 cosine x plus pi over 3 minus 1. And my window should be from -2 pi to 2 pi. Let me give my scale the same scale as I have on this graph here, pi over 6. And I go from -5 to 5. Okay, that's looking pretty similar. I have 2 maximums on this graph. I've got 2 maximums on my graph here, 2 minimums, 2 minimums. It crosses the y-axis just above the x-axis. Okay, and to continue with this topic, we'll take a look at the next notes, which are from section 5.8, which is just taking a look at what happens when we change the b value. So in the last notes, we looked at changing a, and we changed c, and we changed d, but we never did anything with b. So just like we learned in chapter 1, when you change the b value, you're changing the horizontal compression or expansion. When b is a large number, you see compression. When b is a fraction, you see an expansion. And the y values don't change. So let's graph this and take a look. So when we graph sine x along with sine 2x, I'll make sine 2x darker. The sine is a basic wave, and sine 2x fits double as many waves into the window. So I'll graph sine x. The basic sine is like this, and I can copy paste it to fill in the rest of the graph. So there's my basic sine. And now in a different color, I'll put my sine 2x. Sine 2x has the same maximum and minimum, but it fits doubly as many waves. So instead of fitting just one wave from 0 to 2 pi, it fits 2 waves. So this is going from -2 pi to 2 pi, and from -4 to 4. So there's my sine 2x. Okay, that's changing the period of the wave. I graph sine of x with sine of half x, I should expect to see an expansion. So here's the basic sine graph. And now my sine of half x is much, much, much wider. So my basic sine has one wave from 0 to 2 pi. I copy paste it to fill in the negative half. And my sine of a half x fits half as much of a wave. It has the same maximum and the same minimum, but a different period. So again, that's just your basic trig window from negative 2 pi to 2 pi and from negative 4 to 4. So basically when b is a large number, for example like sine of 2x, this is when we see a horizontal compression. And we can fit double as many waves into the same window. When b is a small number like a fraction, then we see a horizontal expansion. Again, if you look on the top graph, when you have sine of 2x, the period becomes smaller. Instead of needing 2 pi to fit one wave, now we need half as much. We only need pi to be able to fit one period. So the period becomes half as big. And this equation puts those words into symbols. So for example, when b is 2, then the period becomes half as big. 2 pi is the normal period. That's just 360 degrees. So when b is 2, the period becomes half as big, so we divide by 2. So 2 pi over b gives you the new period. So now let's put it all together by graphing something like with all the transformations, a, b, c, and d, but without a calculator. So you can think of this from chapter 1 as being 3f of 2x minus 2 pi over 3 minus 1. Now the same trouble that we had in chapter 1 comes up here. The fact that we actually need to factor the b value in order to see what the phase shift is, what the horizontal translation is. So in order to find that c value, I need to think 2 times what number would give me 2 pi over 3. 2 times pi over 3 gives me 2 pi over 3. Now I can fill in my data on my table. So the amplitude is the a value, the absolute value of the a value, which is 3. My b value is 2. C is pi over 3. And d is negative 1. So now what do these things do? The a value gives me a vertical expansion. So instead of going up 1, down 1, to maximum of 1 and minimum of 1, negative 1, it's now going to go up 3 and then down 3 from the middle line. The b value gives me a horizontal compression. So it's going to be 2 times skinnier than it was originally, than the original sine. The c value gives me a horizontal translation. And it's going over to the right. And my d value gives me a translation down 1 unit. Now if I'm going to graph this by hand, the b and c values are quite difficult to graph, but the a and d are not so bad. So when I'm graphing this, I do this in order. I start by graphing the middle line. The middle line occurs at d. So the first thing I'm going to put on is a dotted line to represent the middle of my graph. And that happens at the vertical translation. The second thing I'm going to graph is my amplitude. So the A value means that from the middle line, I'm going to have a wave that goes up 3 and down 3. So above the middle line, I'm going to go up 3. The maximum of that graph is 2. And I'm going to go down 3. So the minimum of that graph is -4. And then I know my wave is stuck between those two red lines. It's going to go up and down in that area. So now the third thing I do is use my C value to find out where I have to start. And in order to do that, I need to know what the basic graph looks like. So I have sine here, so I want to know what the basic sine looks like. So the basic sine starts at 0, 0, goes up, and then down and comes back again. So the basic sine starts right on the middle, and then goes up to the top, down through the middle, and back again. So now instead of starting at 0, 0, here, I'm going to take that point and move it pi over 3 units to the right. So again, each box here is pi over 6. So pi over 3 is the same as 2 boxes. So I'm going to take that middle point and I'm going to move it over 2 boxes to the right. So instead of starting on the y-axis, it starts over 2 points to the right. Finally, I can use my period to find the other points. So the period of the graph is the normal period, which is 2 pi, divided by 2 because it became 2 times smaller. So the period is half as big as normally. Now the period is pi, which is the same as 6 boxes, 6 pi over 6. Each box is pi over 6. So what that means is if I start here and I go over 6 boxes, I should get to the end. So 1, 2, 3, 4, 5, 6, I'm at the end. 1, 2, 3, 4, 5, 6, and I'm at the end of the graph again. Okay, halfway between the two endpoints is another 0. Halfway between the two endpoints, I cross the middle again. So halfway between those endpoints, I'm going to put middle points. I cross the middle line after every 3 boxes. Okay, now starting at the blue dot, first I go up. So halfway between 2 zeros, I have a maximum. So halfway between the 2 middle crossings, it's going to hit the max. Halfway between the next two middle crossings, it hits the minimum. So halfway between those 2 middle crossings, you get the minimum. And then you get a maximum. And we can keep repeating this pattern and fill up the whole graph. And there are my key points. And I just need to connect them with smooth curves. So above the middle line, the graph is concave down. So it looks kind of like a cave shape, nice and curvy. And below the middle line, it's concave up, a bowl shape. And there's my graph of my transformed sine function. So now you can also take a graph that you're given and determine an equation for the graph. Oh, I wanted to check and make sure that my graph is okay. So really, you could graph this one here with a calculator, but again, it's very difficult to see how that would fit on our grid. So I always use my calculator only to check my answer after I've graphed it by hand. So I'll take 3 sine 2x minus 2 pi over 3. I'm doing this before I factor, just in case I made a mistake with factoring. So I have a window from -5 to 5. That's great. Okay, so I have 4 maximums in my window, and I have 4 maximums here. And I cross the y-axis at almost -4, and it looks like the right crossing point on that graph too. Wonderful. So you can also determine an equation given a graph. And there's many right answers for this. And when I look at this graph, what I see is that it crosses the y-axis on the middle line. And I know that sine also crosses the y-axis on the middle line. But the difference between sine and cosine is that sine goes up first, and this one is going down. So maybe if I take the basic sine and reflect it, then it will go down first and then up. And the window is from negative 2 pi to 2 pi. So usually, for a basic sine, from 0 to 2 pi, this will fit one period. But on this graph, I fit 1, 2, 3 ways. So that means my period is 3 times smaller. This is a sine graph that's been compressed 3 times. So that makes me think that an equation for this graph might be the negative sign will reflect it, and I make it 3 times smaller. Let's check if that works. Negative sine 3x. And I'll use the same window as they use here. They went from negative 4 to 4. So 1, 2, 3 ways. Fantastic. But it doesn't quite go high enough. This graph is reaching a maximum of 2 and a minimum of negative 2. So I need to take it and expand it 2 times. So if I put in a 2 for my a value, this should make it become taller. And that looks like the same graph. This is not the only answer. In fact, there's infinitely many solutions. You could also do this with cosine, and I'll leave that for you as a challenge. So the last example is drawing a graph of the cosine function. Again, in this example, the b value has not been factored, so we need to start by factoring out b. And thinking, 4 times what number would give me pi? 4 times pi over 4 would give me pi. So my a value is 2, b is 4, c is pi over 4 units to the right, and d moves my graph up 1 unit. So I'm going up 1, right pi over 4. I'm compressing 4 times smaller in the x direction, and I'm expanding 2 times bigger in the y direction. So again, if I'm going to do this in order, I want to start with my d value. That's the easiest, because the d value is the middle line. So basically what I'm doing is I'm taking the basic cosine graph. And the basic cosine starts at 0, 1. And I'm going to take that, expand it 2 times in the y direction, 4 times compression in the x direction, move it right 1 and up 1. So the middle line of this graph is going to move up 1. So I'm going to put that line on the graph first. I'm moving the whole center of the graph up 1. And then from there, I have an amplitude of 2. So that means from there I'm going to go up 2, down 2, up 2, down 2 from the middle. So the maximum of that graph will be 3, and the minimum will be negative 1. The third thing that I do is use the c value to find out where the graph starts. So normally cosine starts on the y-axis. So normally I would expect to start here. But I have a c value that's shifting me right pi over 4 units. Now if I use the same scale as I do before, pi over 4 is kind of hard to find. How many pi over 6s is that? And we can do pi over 4 divided by pi over 6 to find out how many boxes are there. 1.5 boxes. So pi over 4 units right means I'm taking that point and I'm moving it 1.5 boxes to the right. So instead of starting on the y-axis, the graph actually starts 1.5 boxes to the right. Okay, so there I've got my starting point. Now I'm going to use the b value to find the period, which will tell me how often it repeats. So the period is 2 pi divided by b, which is pi over 2. How many boxes is that? Each box is pi over 6. So pi over 2 would be 3 boxes. So that means after 3 boxes, I'm going to be right back where I started. So 1, 2, 3, and I'm at a maximum. 1, 2, 3. Every 3 boxes, I hit a maximum again. 1, 2, 3. 1, 2, 3. Now, just like a sine graph, halfway between 2 maximums is a minimum. So halfway between those 2 maxes, I get to the very bottom. Halfway between 2 maxes, I get a minimum. And halfway between a maximum and a minimum, I cross the middle line. Now that's kind of hard to draw. It's kind of like 0.75 and 0.25. 0.75, 0.25, 0.75, 0.25. Now I'll connect the tops concave down. Connect the bottoms concave up, bowl-shaped. And there's my graph. I'll verify it with my graphing calculator to make sure that I didn't make any mistakes. So 2 cosine 4x minus pi plus 1. Use the same window, and they go from -5 to 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 maximums. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And it goes from -1 up to 3. So does mine. And it crosses the y-axis at a negative. Yay! It looks great. So to practice transformations in your Michelson book, look at page 242, numbers 1 to 10.